In this video lectures, we're going to discuss more about what are the others filter that we have which can represent our restoration filter. So far we have discovered a lot of filter like what I've mentioned before. Okay, when we talk about we already cover the family of mean filter. Okay, like I mentioned before, this one, if you talk about image enhancement, actually this is related to kernel based neighborhood processing. And then we also talk about the order statistic filter, where actually this one is related to non-linear filter or non-kernel based neighborhood processing that we have discussed in image enhancements. Okay, other than these two category, we also have some other filter that can be used as a restoration filter. Okay, one of it is what we call as a alpha trim mean filter. Okay, why we separate, even this one is the name is same, I mean the name is alpha trim mean filter, but we put it separate from the mean family filter, because this filter is actually I can consider it as the hybrid between the mean filter or the mean family filter and the median filter, which is under statistic order statistic filter. So later we will try later we will discuss about how actually we compute the alpha mean trim mean filter, and then you will realize that actually the mechanism inside this filter is a hybrid between the mean filter as well as the median filter. Okay, the combination of median and mean filter in same or in single filter. Okay, to discuss the alpha trim mean filter, okay, we're going to use the same whiteboard here. So I already paste the equation there. This is the equation that represent the alpha trim mean filter, and then let's discuss about this tag where this is actually is from your slide. Okay, so if you realize that from this filter, one of the things that different about this filter with others is that you can see that the G there have a subscript R there. There's a subscript R there. Okay, a small r there. However, the rest of the filter you don't have that one. Okay, like this one. Okay, you don't have that one. So actually, there's a meaning behind this one. Okay, how actually this filter works is, okay, first you need to do some assumption, because there's a lot of variables there. You have M, N, and D, and so on. So okay, D is actually to determine how many item you want to trim. Okay, another word, okay, assume that in my example, I just assume my D is equal to 2. Okay, so if you are using this filter and then you set your D equal to 2, so what actually happen, okay, when you apply this filter, okay, the first step, what this filter do, again, this is the filter will proceed the same thing. Okay, that's why they use SXY there, that represent the box. Okay, the box of the filter. So assume this is our box, the same thing. Okay, 3 times 3, and then this is our XXY. Okay, so what this filter do, first it will implement some sort like your median filter, meaning it will sort in the ascending order. So let's say this is my, okay, that is actually represent your GXY. Okay, your set of GXY. First, let's say your this is the set. You have A, B, C, D, E. Sorry. Okay, again, a GXY is a set of item that inside this red box. Okay, so your A, B, C, E, F, G, I, J, K, and then assume that this set, after you are doing you sort into ascending order, then it will become something like this: B, C, E, A, G, F, J, I, K. So assume that this is the arrangement. meaning that now after you apply, you sort into ascending order. K is the maximum value and B is the minimum value. Okay, if you decide to set the D is equal to 2, then it's actually after this filter sort the set of numbers here or set of pixels here into ascending order. Actually you need what does this filter do? It will trim it will trim some item, it will remove some item. Okay, when you set it in D equal to 2, means that it will trim, or it will remove one at the most left and one at the most right after in this set of number where you already sort it into ascending order. So if the D equal to 2, then you need to remove the item one at the most left, which is this one. Okay, we will remove this one, and we will remove this one, meaning that we will remove the B and we remove the K, because B is the most left and K is the most right. So what is the meaning by D equal to 2? This is this one. You need to remove two items. Okay, so meaning that one from your left and one from your right. And this actually, after you remove, the remaining set here is actually your G, a set of your GRST. Okay, which is this one. Okay, of course there's a summation symbols there, so that's why you need to compute this one. You need to total up this one, C plus E plus A plus G plus 4, C plus E plus A plus G plus F plus J plus I. Then you need to divide with how many items here? 1 2 3 4 5 6. Okay, you need to divide by 6. That is actually represent this 1 over mn minus D, where actually this one, okay, is actually 9. Okay, m times n is the 3 times 3 in this case, then minus your D, then it's equal to how many there? That one is 7, right? So 7. So that's why this one you plus together all the remaining, which is this one, this one, this one, this one, this one, and this one. So okay, I'm sorry, it's not 6 and it's 7. 1 2 3 4 5 6 7. So you total up together, you divide by 7. So that is that operation is represent this summation as well as this factorial be at the outside here. Okay, 1 over 7 plus multiply with C plus E plus A plus G plus F plus J and plus I. So that's how you implement this alpha trim min filter. So in other words, you can see that the mechanism of sort the value into ascending order is seem to be like your median filter, and at the end you are not choosing the center like median filter, but you are trim. Once you trim the remaining item left, you must get the average or get the means. Okay, that's why you total up together and you divide by how many number left. Okay, the number of the item left here is 7, because you are removing 2, which is 1 from the most left and then 1 from the most right. Okay, so in other words, in order for you to apply mean filter, this D, okay, this D here should be in even number. Okay, you cannot set as a odd number, because odd number cannot divide by 2, because when you set the D equal to even number, then it will fair to set, to remove half of the item from the left, half of the item from the right. Okay, so that's why you can choose the D equal to 2, D equal to 4, D equal to 6. Okay, so that is how you implement the alpha 3 min filter. So the rest of the discussion, as you can see there, okay, it's very useful in the situation involve multiple type of noise, such as combination of SAS and paper and Gaussian. So of course it can remove that, because as you can see the hybrid there, the hybrid mechanism means that you also a part of the median is there and a part of the mean is there. So that's why it can solve the noise, the image that affected with combination noise like SAS and paper and Gaussian. And this is some explanation. Is if you set the d equal to 0, okay, again this one you can try. Okay, if you set your d equal to 0, so nothing, when d equal to 0, nothing, there's no item you will trim, or there's no item you remove from this set of ascending order. But at the end you need to, now the definition now is a little bit is a little bit changed. Now your GR is not removing any item, so your GR is actually a full set of this ascending item, ascending set pixel that you have already sort into ascending order. So if you total up together and then you must divide by 9, then it actually looks like your arithmetic mean, meaning that you are not trim at all. Okay, if you don't trim at all, means that it become arithmetic mean. So if you set your d equal to mn minus 1, so what is mn minus 1? In our case is 9. Okay, 9 minus 1, which is our 8. So if you set your d equal to 8, so it seems to be you are removing the 4 item from the most left. Okay, the most left, which is this one, and then you are removing also the 4 item for the most right. At the end, the one that leave is, or the one that you leave here is the GR here is only this one. So and of course this one minus, divide by 1, then you get back this one. So in other word, if you set your d equal to mn minus 1, it will become median filter.